Hi, Seedsforthefuture. My name is Miguel Brito, and I am a CS student deeply passionate about using technologies to address climate change. This passion has led me to participate in several hackathons, always looking forward for ways to apply data-driven solutions to real-world environmental challenges. Today I'm really excited to present to you Optirutas, an intelligent system born with a passion designed to solve one of the most complex and costly logical problems in our cities: waste collection. Every day, fleets of trucks travel our streets, but have we ever wondered if their routes are efficient? The reality is that manual or suboptimal planning generates enormous costs, more fuel, more working hours, and above all, a greater environmental impact. The challenge, known as vehicle routing problem, is to find the perfect set of routes to minimize the total distance traveled, while respecting constraints like truck capacity and operational time windows. Solving this efficiently means saving money and reducing emissions, and that is the mission of our project. To solve this, we have built a web application that uses multi-object genetic algorithm NGA to This algorithm doesn't just find the shortest path, it finds the perfect balance between distance, vehicle load, and time. The key innovation is that we've moved beyond simple street distances. Our application connects with MacBook AP to calculate routes based on the actual street network, giving us unprecedented real-world accuracy. The entire system runs on the cloud, using a modern and scalable architecture with Docker and Azure container apps, ensuring it's always available and can handle problems of any size. But instead of just telling you, let me show you how it works. This is our interface, and this is where all the app will be contained. Here are all the here you can put all the data from the different route collection garbage trucks. Here we can see you can input the number of vehicles, the capacity, the operational window, and even the times where they will operate. If any of these constraints is broken, the genetic algorithm will make a penalization to this solution, and therefore there will be no solutions that are outside of the window frame. Let's start by selecting a location where the depot of the trucks will be. Here it is. Now let's select the containers and where they will be positioned in the map. Here we selected random points in the city, and this is the important part. It offers flexibility to private companies and public governments to select where the containers will be at. Then we input what is the demand that should be calculated before of each container. And we can even save the scenario or load previous scenarios. Well, let's optimize the route. Here we can see the results. As you can see, we can see optimization results. We can see in every vehicle the distance traveled and the time. And we can even export the results by the scenario or even as routes for a GPS app. And it will even generate itineraries. So here we can see the routes are tracked. Saves the fuel, maintenance, and labor costs. But more importantly, there are fewer kilometers driven means a direct reduction in the carbon footprint, contributing to a more sustainable cities. And most importantly, it transforms decision making. It moves from a manual process based on intuition to an optimized data-driven strategy, allowing companies to be more efficient and competitive. The potential for this technology is enormous and can be applied to any logistic industry. Thank you for your attention.